Students, how are you? I'm Mr. Wandamagan, who is your mathematics teacher. Today we are interested to see about Unit 2. The topic at Unit 2 is polynomial functions. Okay, the learning outcomes. That means after learning this lesson, students should or must understand the followings, or that are learning outcomes. At the end of this unit, you will be able to, number one, define polynomial function. After learning this lesson, students should be able to define polynomial function. They should be able to perform the four fundamental operations on polynomials and apply theorems on polynomial functions to solve related problems. Determine the number of rational and irrational zeros of polynomials. Sketch the graphs of polynomial functions. These are the main parts. Now, main contents. That's we should see or we should learn in this lesson are the followings. The main contents. The first one is introduction of polynomial functions. The second content will be operations on polynomial functions. Then the other content is theorems on polynomial functions. Then the other is zeros of polynomial functions. And we will see also the other content is graphs of polynomial functions. And finally we will see applications of polynomial function. The k-terms. These k-terms are very important. Now let's see about different k-terms are introduced here. Not only k-terms. Let's start about the introduction part. This is introduction because it helps you to understand polynomial function, or it gives some clear or main important points. Before entering into polynomial function, looking or observing the introduction part is very important. Introduction. In Unit 1 of this textbook, you saw functions of the form y is equal to ax plus b. That means in grade 10. In Unit 1, you are familiar with this kind of function, y is equal to ax plus b. Here, the exponent of x is 1, and such kind of function, and when a and b are any real numbers, but especially a should be different from 0, is linear function. A different from 0 because if a is 0, a times x will become 0 and y is equal to b will become constant function. The name linear will be changed. And also you are familiar with these functions in this unit, at Unit 1 in this grade 10 mathematics. This is the form ax squared plus bx plus. This is called quadratic expressions. Now you will also attempting to sketch their graphs. These functions are parts of a large class of functions called polynomial functions. Polynomial functions are functions that involves only one variable x, consisting of the sum of the several terms. Each term is product of two factors, the first being a real number coefficient and the second being x raised to some non-negative integer power. In this unit, you will be looking at the different components of polynomial functions like degree, leading coefficient, zeros of polynomial functions, properties of graphs of polynomial functions. All this will be seen in this lesson. So you will see how the leading coefficient and the degree of polynomial function determine the end property of their graph of function. That means leading coefficient and degree determine the property of the function of polynomial function. Degree and the leading coefficient can determine this. Introduction to polynomial function. You are familiar with functions like constant function, linear functions, and quadratic functions in Unit 1. Let's observe this activity or activity 2.1. Classify the following functions as constant function, linear function, quadratic functions, or none of these. When you see a, f of x is equal to 2x plus 4. Look, the power or the exponent at x, the exponent of x will be 1. Now this one is linear function. B, g of x is equal to 2 over 3 minus x. Here the exponent is still, it is 1, it is linear function. F of x is equal to absolute value of x. This function is said to be absolute value function. F of x is equal to x is x if x is greater or equal to 0. That means the value will be itself if x is greater or equal to 0, or if x is positive and 0. And f of x, absolute value of x, will be minus x. That will be its opposite if x is less than 0. D, h of x is equal to this minus x squared plus 5x plus 9. When you observe this is a quadratic function, which is this kind. Quadratic function is called second degree function. The highest exponent in quadratic function is 0. E, f of x is equal to x raised to 4 plus 2x minus 5. This function is not linear because the highest exponent is greater than 1, not quadratic because the highest exponent is again greater than 2, or it's not constant function because of there is a variable. Then none of this, you can say none of this. F, k of x is equal to 5. This is constant function. K of x, f of x, g of x is equal to any real number is constant function. H of x is equal to x minus 2 times x plus 2. Look, the multiplicity here is 1, the multiplicity here is 1, then 1 plus 1 will be 2, then this will become quadratic. To observe this also, you can multiply x times in x plus 2 minus 2 times x plus 2, or you can multiply x times x and x plus x times x is x squared plus x times 2x is 2x plus minus 2 times x is minus 2x minus 2 times 2 is minus 4. That means from this you understand, after finding the product of these factors, these linear factors, you will get quadratic. The highest exponent will be 2. H, f of x is equal to 6 plus 9 over 5x plus 4x. Look, the highest exponent here is 2. It is quadratic function. F of x is equal to minus root 5x plus root 2. Here, whatever the coefficient is any linear, it's possible, but this x should be out. Now this x is out of the radical, then the exponent here is 1. It's linear. L of x is equal to 3 root of x plus. This one is even not polynomial, then none of them not polynomial, because polynomial function has always exponent is non-negative integer. Okay, a function f is constant function if it can be written in the form of f of x equal to b, where b is real number. The domain of f is the set of all real numbers, and the range is the set containing only the number p. For this kind, the domain is only number, whereas the range is p. A function f is linear function if it can be written in the form of f of x is equal to ax plus b. Now, where the coefficient of x here is a, should be different from 0 because it's linear, because the exponent of x is 1. If a is 0, a times x will be banished, or a times x will be 0, and it has the form f of x is equal to b. Now the name linear is changed. To be linear, a should be different from a. Good. Now let's see this concept. A and b are real numbers. The domain of f is the set of all real numbers. That means the domain of any linear function is the set of all number, and the range is also the set of all number. For linear function, the domain as well as the range is all real number. A function f is quadratic function if it can be written in the form of f of x equal to ax squared plus bx plus c. A different from 0, because to be quadratic, the highest exponent should be 2. If a is 0, now this part vanish, and now just it changed to linear. Therefore, to be quadratic, A should be different from 0. Where A, B, C are in numbers, the domain of F is the set of all the numbers. That means the domain of any quadratic function is all the number, but the range is different. And the range is not the set of all the numbers, and it depends on the value of A, B, and C. That means the range of quadratic function depends upon the coefficients. It depends upon the value of A, B, C. Good. Definition of polynomial functions. We will see definition of polynomial function in next period. This is enough for today. Goodbye, students.